Hi everyone! Today we're going to study vector algebraic operations. Let V be a vector represented by V equals xi plus yj plus zk. Or we can represent it this way: V equals x, y, z. Now given two vectors, vector A equals a sub 1i plus a sub 2j plus a sub 3k, and vector B equals b sub 1i plus b sub 2j plus b sub 3k. Then vector A plus vector B, this is addition of vectors, equals the quantity a sub 1 plus b sub 1 times I, plus the quantity a sub 2 plus b sub 2 times j, plus the quantity a sub 3 plus b sub 3 times k. For vector A minus vector B, this is about subtraction of vectors. This is equal to the quantity a sub 1 minus b sub 1 times I, plus the quantity a sub 2 minus b sub 2 times j, plus the quantity a sub 3 minus b sub 3 times k. Now let's have this lambda times vector A. Lambda here is a scalar. In this case, the operation is multiplication of a vector by scalar. So this is equal to lambda a sub 1 I plus lambda a sub 2 j plus lambda a sub 3 k. Example 1. If vector A equals 5i plus j and vector B equals 4i minus 7j, find 3a minus 2b. First, let us list the corresponding vectors. Our goal here is to evaluate 3a minus 2b. Let us start with 3a. It means we're going to multiply the constant 3 to vector A. So it will be like this: 3a equals 3 times the quantity 5i plus j. Simplifying this, we multiply 3 to each term of the vector. So we have 15i plus 3j. Then we move to 2b. We multiply the constant 2 to vector b. So we have 2b equals 2 times the quantity 4i minus 7j. And this will be simplified into 8i minus 14j. Now, let us substitute the corresponding values here. The 3a is the quantity 15i plus 3j minus the 2b is the 8i minus 14j. Removing the grouping symbol, we will have this 15i plus 3j minus 8i plus 14j. Then we combine similar terms. So we have this 15 minus 8 multiplied by I plus the quantity 3 plus 14 times j. So the final answer is 7i plus 17j. Example 2. If A equals 2i minus j plus 4k and B equals I plus j plus 2k, find A plus phi B. Let us list the corresponding vectors here. Then our goal is to evaluate A plus phi B. For the A, we can just simply copy the value here. Now let us evaluate the phi B. We are going to multiply the constant 5 to vector B. So 5b equals 5 times the quantity I plus j plus 2k. And this will be simplified into 5i plus 5j plus 10k. Now, we're ready to substitute the corresponding values. The a is the 2i minus j plus 4k plus the 5b, that is 5i plus 5j plus 10k. We can now combine similar terms. So we have 2 plus 5 multiplied by I plus the negative 1 plus 5 multiplied by j plus the 4 plus the 10 multiplied by k. Simplifying now, the 2 plus 5 is 7i, negative 1 plus 5 is positive 4, then we write the j, plus 4 plus 10 is 14, then we write the k. This is now the final answer. Today we're going to study unit vector. Let's begin the lecture with zero vector. The zero vector in space is the vector 0. And this is represented by 0, 0, 0. Or we can write like this: 0i plus 0j plus 0k. Vector 0 has 0 length and no direction. Now let's go to unit vector. A unit vector in space is a vector of length 1. We have here standard unit vectors: vector I, vector j, and vector k. The vector I is equal to 1i plus 0j plus 0k. Vector j equals 0i plus 1j plus 0k. Vector k equals 0i plus 0j plus 1k. We call these standard unit vectors because if we take the length of these vectors and using our formula, we will have like this. For the length of I, this is equal to the square root of 1 square plus 0 square plus 0 square. The length of vector j equals the square root of 0 square plus 1 square plus 0 square. The length of vector k equals the square root of 0 square plus 0 square plus 1 square. Simplifying the radicals, we will get 1, 1, and 1. Now let's go to the topic unit vector in the direction of v. Given the vector v, which is not equal to 0, the unit vector in the direction of v is equal to the vector v all over the length of v. In symbol, we can write like this: v all over the length of v. This is now our working formula. Example 1. Find the unit vector in the direction of 3i minus 4j. This is the formula for the unit vector in the direction of v. When we substitute our value, we will have unit vector in the direction of 3i minus 4j equals 3i minus 4j all over the length of 3i minus 4j. In solving this, we should first evaluate the denominator, the length of 3i minus 4j. Using our formula, we will have this big square root of the coefficient of I, that is 3, we put square, plus coefficient of j, the negative 4, we put the square. Simplifying their squares here, we have now the big square root of 9 plus 16. And this is simplified into square root of 25. That becomes 5. Now the step 2 is here. Evaluate the unit vector in the direction of v. And our formula, v over length of v. This denominator is already solved in our step 1. So we can substitute the value in here. So we have 3i minus 4j all over 5. So what we're going to do here is to split the terms of the numerator with respect to the denominator. So we have now 3 over 5 times I minus 4 over 5 times j. This is now the final answer. Example 2. Find the unit vector in the direction of 2i plus j minus 3k. The unit vector in the direction of 2i plus j minus 3k equals, our formula now is 2i plus j minus 3k all over the length of 2i plus j minus 3k. So for the step 1, let us evaluate the denominator, the length of 2i plus j minus 3k. So we have this big square root. The coefficient of I, that is 2, we put a square, plus coefficient of j, which is 1, we put a square, plus coefficient of k, that is negative 3, and we put the square. Now let us simplify the squares inside the radical. So we have now 2 square becomes 4, 1 square becomes 1, square of negative 3 is positive 9. So this is simplified into square root of 14. Now step 2, let's now evaluate the unit vector in the direction of the vector 2i plus j minus 3k all over the length of 2i plus j minus 3k. Substituting the value from step 1, the denominator becomes square root of 14. Let us now split the terms of numerator with respect to our denominator. So we have now this 2 over square root of 14 times I plus 1 over square root of 14 times j minus 3 over square root of 14 times k. If we rationalize the denominator, we will have this expression 2 square root of 14 over 14 times I plus square root of 14 over 14 times j minus 3 times the square root of 14 over 14 times k. We can see here that the first fraction here can be simplified. So we have now square root of 14 over 7 times I plus, we'll just copy the remaining terms. This is now the final answer. Example 3. Find a unit vector in the direction of p sub 1, 1, 0, 1 and p sub 2, 3, 2, 0. For the step 1, we're going to write the component form of the vector p1, p2. So this will be 3 minus 1, that is times I, plus the quantity 2 minus 0 times j, plus the quantity 0 minus 1 times k. And this will be simplified into 2i plus 2j minus k. This is now the vector. Now for step 2, we will evaluate the length of the vector from step 1. So using our formula, we will have the square root of 2 square plus 2 square plus the square of negative 1. Simplifying the squares inside the radical, we have now 4 plus 4 plus 1, which is equal to square root of 9 and can be simplified into 3. Step 3, We will now evaluate the unit vector in the direction of P1, P2. In the numerator, we will copy our answer from step 1. All over the denominator, we will copy our answer from step 2. And from here, we will split the terms of the numerator with respect to denominator. So we have now this 2/3 times I plus 2/3 times j minus 1/3 times k. This is now the final answer. I hope you learned something from this video. See you again next time.